Hello, grade sevens, and welcome to your mathematics brought to you by Worksheet Cloud. Trust you guys had a good weekend and are looking forward to getting into some work this week. Remember, you were due to go back to school this week, so it's important for you guys to get back into the swing of doing your studies. The longer you leave it, the more difficult it's going to be to get back into it. Even if you're not keen, do yourselves a favor and get some work done every single day. Okay. Our structure or our schedule for today is in front of you, a little warm up followed by some mental questions. Then we're going to look at prime factors. Remember last week we looked at multiples, factors, and prime numbers. So this week we'll delve in a little bit deeper into prime factors. And then I have a brain bender and a finisher for you to complete towards the end of the lesson. Right, our warm-up activity for today is as follows. Um, Remember, you need to use your math skills to work out the value of the icons or symbols, and then remember to work out the pink question mark at the end. Guys, really important for you to stick with the problem, really important for you to finish it. If you're struggling, struggle through the problem, and really be determined to get the answer at the end. Right, off you go. Okay, I'm going to carry on there. Just remember that if you don't finish an R carry on, you can press pause, continue to work it out, and then press play to see how it unfolds. Okay, guys. But again, please try get this done. Right. So I'm going to start here because I know that the flags and the balloons are equal. Okay, so that's my first clue. But then I'm going to go down to the third line, and because I know that the balloons and the flags are equal, I'm going to go 2 multiplied by 2 multiplied by 2 is equal to that 8. Remember, we can also write this as 2 cubed. Okay. So then I know that 2 equals 2, and I'm just going to fill in wherever the 2 might be. Okay. So then let's see what happens. Now, you need to use a method called trial and error to work numbers out, and you need to keep using that until you get the correct answers for the symbols and it actually makes sense. So I know that 2 minus 1 is equal to 1. Okay, now I'm not sure if that's going to work. Those are just the numbers that I've chosen to use. I might have to go back and correct it. Okay, but I'm going to have a look at the top, and I know that 1 plus 7 plus 1 is equal to that 9. Okay, um, and then I've just got to go down to the bottom of the page, and I know that there's 7 goes into there, and I need to subtract 1, and I'll put my answer at the bottom, and you know that from order of operations, your multiplication comes before your subtraction and your addition. So I do the 7 groups of 2, which is 14. Then I can subtract the 1, which is 13, and add the 2 to give me 15. Okay? Right, well done if you got it. If you struggled through it and then you eventually got it and you tried different numbers and you went back and you tried again, even better, guys. Okay, well done. Okay, let's move on. Your mental maths questions for today are in front of you. I'll give you a minute or so to work it out. And again, remember that you can press pause if I start talking too soon, and you can work them out and then press play again to see how you fared. Off you go. Okay. Right. There are your, I've just jotted them down quickly. So this first question over here, what is 2 times 2 times 2 times 2? It's 2 to the power 4, and obviously 2 to the power 4 is the same as 2 times 2 times 2 times 2. So that's just writing using exponents. Okay, then 6 minus the 0.3, so that's going to give you 5.7. Okay, then this method, this question over here has got to do with last week. There was a double and halving strategy that I spoke about, and what it involved was you double one number and you halve the other. So as you can see, I've halved the 8 to get 4, and I've doubled the 12 to get 24. Then I've done half 4 again to 2, and I've doubled the 24 to 48. And all I've done there is I've manipulated the numbers to make the sum a little bit easier. Okay, so you can do that when you have two even numbers, or when you have an even and an odd number. Okay, the next question was the lowest common multiple of 9 and 4. So I've just written out the 9 times table there and the 4 times table there. And remember, the lowest common multiple is the lowest number that occurs in both sets. So you should be able to see that 36 is the one that is repeated in both sets. Okay, right, your next question was the highest common factor of 24 and 18. And if I just write out the factors of 24, I am going to get 1, 2, 3, 4, 6, 8, 12, and 24. And remember, we spoke about writing them in order, so that the 1 and the 24 multiply together to give you 24, the 2 and the 12 to give you 24, the 3 and the 8, and then the 4 and the 6. And we spoke last week about joining those smiley faces just to make sure we hadn't left any out. The other number was 18. Okay, so that's 1, 2, 3, 6, 9, and 18. Okay, and I'm hoping you guys can recognize that it is the 6 that has been repeated in both sets. So therefore your lowest common multiple, your highest common factor of 24 and 18 is 6. Okay. Okay, guys. So that's our mental maths for the day. Well done if you got through all 5 questions. If you didn't and you don't understand, then remember to pause, go back, and make sure that you understand and gain clarity in everything that you do. Okay. Right. The next section we move on to is prime numbers. You'll remember last week we spoke about prime numbers having only 2 factors, themselves and the number 1. So for example, 3 can only be divided by 3 and 1, so it's therefore a prime number. So today we're going to look a bit deeper into prime numbers, but just before we do that, I quite often get asked in class, so what's the point? Why are we learning this? Why are you teaching us this stuff? How are we ever going to use it? And prime numbers are really, really important. Okay, they are used in encryption. So encryption is the science of encoding secret messages. So you can think of the military, you can think of spies, countries not wanting other countries to know what they're getting up to. They encrypt their messages using prime numbers. Every time you go to the bank and you or your parents draw money out of the ATM, there's an encryption code between the bank and your particular bank account and the ATM and your debit card. And that is also used and protected using prime numbers. And then one of the other areas that it's widely used is computer security experts who try and make computer programs that hackers can't get into. A very difficult industry, but very lucrative. Okay, so the largest prime number is this one over here, and that is 2 to the power of 82,589,933. Okay, a massive number. That number has 24,862,048 digits. Now, it was my intention to try get that number onto a slide for you, but 24 million plus digits takes multiple slides, and I didn't think that it'd be worth your while to see a whole lot of slides with a whole lot of numbers on it. Okay, so prime numbers, really, really, really important. They're busy looking for the next prime number. Whoever finds the next prime number is going to be a lucky man. Today we're going to look at prime factor decomposition. Okay, now decomposition means breaking up. When something decomposes, piece of food, piece of fruit, or whatever, when it decomposes, it breaks up into its individual components, into its smallest part. So every positive integer, so every positive number, can be written as a product of its prime factors. So what that means is every positive number can be written as a multiply sum using its prime factors. Okay, now to find out the prime factors of a number, we use two different methods. There's the ladder method and there is the tree method. Now the ladder method is called the tree method. The ladder method is called the ladder method because it looks like a ladder, and a tree method is called the tree method because it looks like the branches of a tree, or supposed to look like the branches of a tree. Okay, so you can see 168 has first been divided by 2, then that gives you the 84. Then that can be divided by 2, and that 84 divided by 2 gives you 42. Then that 42 divided by 2 gives you 21, and that 21 is then divided by 3, and that gives you 7. So notice that I've only divided by prime numbers. 2 is a prime number, 3 is a prime number, 7 is a prime number at the end. When you get a prime number at the end, you know that your job is done. Okay? Then you can write 168 using these prime factors. Okay? 2 cubed, because there are 1, 2, 3 of them, multiplied by the 3, and then multiplied by the 7. Now, if you work this out and you checked, you would notice that 2 cubed is 8, and times 3 is 24, and then 24 multiplied by 7 is 168. Okay, so that would be your ladder method. Okay, your tree method has used the number 24. So what they've done is they've gone and found 2 factors of 24. So 6 multiplied by 4 gives you the 24. And then they've gone and they've split that 6 into its prime factors, because 3 times 2 is 6. And they've split that 4 into its prime factors. 2 times 2 gives you the 4. There are 1, 2, 3 number 2s, so we write 2 cubed. 2 times 2 times 2 times 3. So remember, 2 cubed is 8, times 3 gives you your original 24. Okay? Now, when we write it using exponents, we call it exponential form. Okay? Perhaps your teachers use a different terminology there. what I'm going to get you guys to do now is I actually want you to practice doing those ladder method and tree method. So the first thing you're going to do is you're going to go 54 in a ladder method, then 100 in a tree method, and then 240 in a method of your choice. So let's have a look at the first one, okay? And feel free to work through this with me. So first of all, we've got 54, and we've said use the ladder method. You can have the 54 with the line on the right or the left. It's entirely up to you, okay? So the way I like to do it is I say to myself, what is the lowest prime number that goes into 54? And we know it's even, so therefore it must be 2. 2 goes into 54 27 times. Okay? Now what's the lowest prime number that can go into 27? It's not 2, so because we know our multiples so well, we know that it's 3. Okay? And 3 goes into that 27 9 times. Alright? What prime number goes into 9? 3. And 3 goes into 9 3 times. Okay? What prime number goes into 3? 3. Okay? And then you know you're done, because 3 divided by 3 is 1, and when you get to 1, well, you can't go any further. So how do I write that now using exponents? I use 2 multiplied by 3, multiplied by 3, multiplied by 3. Okay, but then we write it as 2 multiplied by 3 cubed. And as I've said to you before, it's always really important to check. 3 cubed is 27, and you know that 2 times 27 is 54. Okay, so let's just remove that and have a look at the next one. So the next one is the tree method, and I'll try my best to make it look like a tree. So we have 100. Okay, now you can split 100 up into what you think is the smallest prime number that goes into it is 2. Goes into it 50 times. When you have a prime number at the end of one of the branches, okay, this here being a branch, okay, then you can circle it, and that branch goes no further. So once you circle it, there's a little apple on the end of that branch, and you can't go any further. But 50 can be further divided by 2, and that goes into 50 25 times. Okay, so what's the lowest prime number that can go into 25? Is 5 and 5. And what I have not done is, there's my apple, and that's prime, and that's prime. So therefore, I cannot go any further. So that should be 2 times 2 times 5 times 5. And we write that as 2 squared times 5 squared. And you know 2 squared is 4. And you know 5 squared is 25. So you can check, and you know that equals 100. Sorry about that little lost out of space there a little bit. But that equals 100. Okay? So that's the tree method. Now the interesting thing can be, you didn't have to start with dividing by 2 and by 50. Okay, you could have started using additional numbers. Okay, so if I had 100, let's just wait for it to clear out. Okay, I could have said 10 times 10. Okay, and then I could have said 2 times 5 and 2 times 5. Okay, and there you'll notice you've got exactly the same ending. Okay, you've got 2 times 2 times 5 times 5, and as we've already discussed, that's 2 squared times 5 squared, which, as you saw in the previous slide, is equal to 100. So you've got options there, boys and girls. You could have gone 4 times 25, and you would have ended up in the exact same place. Okay? But it's really important to write your answer using those exponents as I've shown you at the bottom. Okay, I'm going to give you an opportunity now to do 240, question C. Do that using a ladder or a factor tree method. I'm going to do both of them for you, and then we'll move on. Okay, but get on with the 240 while I clean this board up. Okay, ladder method first. Guys, remember that if you haven't finished and I'm carrying on before you finished, press pause, give it a shot, and then press play to see how you went. So the lowest prime number into 240 is 2, and that goes 120 times. Then that 120 is still even, so it's another 2, and that's 60 times. That's still even, so it's another 2, and that's 30 times. That's still even, so it's 2, and that goes 15. So the next prime number that goes into 15 is 5, and that goes 3 times. 3 goes into 3 once, and we get to that 1, and we know that we are finished. Okay? Then to write that out, 2 to the power of 4, because there are 1, 2, 3, 4 of them. Okay? Times 5 times 3. Okay, now if we work out 2 to the power of 4, it's 16. 2 times itself 4 times is 16. Multiplied by 5, okay, is 80. And 80 multiplied by 3 is going to give me that original number of 240. Okay. So let's clean that, and if you haven't attempted the factor tree method, then give that a shot now while I clean up this board, and let's see how you go with that. Okay, so I'm just going to use the lowest prime number I know of, and that's 2, and that goes in 120 times. Okay, then 2 again, and that goes in 60 times. 2 again, and 30. 2 and 15. I'm going to run out of space here. 3 and 5. Okay, actually, now I'm good. All right, and then just remember, like I said to you, I like to circle the prime numbers. Okay, so I know what I'm working with. And then I've got 1, 2, 3, 4, 2. So 2 to the power of 4 times 3 times 5. And as you saw earlier, yeah, that's equal to 240. Again, if you didn't choose 2 and 120, you could have gone, perhaps you could have gone 60 times 4, and then there's your 2 and your 2, and then 60 would have ended up into 2, and 30 would have ended up into 30 would have ended up into 2 and 15, and then that would have ended up into 3 times 5, and again you can see there's 5, 3, 2, 2, 2, and 2. So it's exactly the same again. 2 to the power 4 times 3 times 5. Okay? So again, it doesn't matter what number you break up the original number into, as long as they multiply back together to give you 240. Okay. Right, that's our main part of the lesson done for today. So your last little finisher activity are those 2 questions. I'm going to give you a little bit of time to work out the first one, and the second one I'm going to leave with you, and we're going to start off with that tomorrow at the beginning of the lesson. Off you go with the one on the left. Remember, all 4 boxes need to add up to 350. Those 4 boxes there need to add up to 350. Okay, I'm going to carry on. So again, remember, if I'm carrying on and you're not finished, then just pause, struggle through it if you are struggling, and make sure that you get to the other side. So the first thing I know is that this 6 times this 2 is going to give me that 12. That little prawn over there is equal to 12. Okay? Let's write that again. That's 12. Okay? So then I can use trial and error. Okay, sometimes you don't get the answer immediately, and I'm going to work out that that's 10 and that's 20, because 10 multiplied by 20 is going to give me this 200. Okay, this 6 multiplied by this 20 is going to give me 120. Okay, and then this 6, and I'll take it all the way around the outside, multiplied by that 2. Okay, oh, actually, sorry, I made a mistake there. Right, it doesn't matter. I've identified it and we'll correct it. Okay, that 6, sorry, should not be multiplying by that 2. It should be this 10 multiplied by that 2. And that's going to give me 20. Okay, and then if I add up that 200, that 120, the 20, and the 12, that should give me 352. Okay, so guys, I've just shown you can make mistakes. I make mistakes all the time, but it's important that you identify them and that you correct them and you understand your errors. Okay. Remember this problem here that I've left for you. So pause it, work it out, trial and error, try things out, see what numbers work, and we'll get into the answer tomorrow. Okay. Right, guys, have a great evening. Enjoy the time with your families and keep safe. All the best.